All right, so this video we're going to look at series circuits and some of the rules that apply to them and how to do the calculations. So a series circuit essentially means that we have a single path for electricity to flow through a resistor to ground. All right, and we know that, and again, I'm going to continue to draw the circuits like this, but we know that in essence, this ground is completing the circuit back to my my voltage source. That must be true in order for it to be a circuit. If the circuit becomes broken at any point, no current will flow, nothing will happen. All right, so we're going to have a look at series circuits. Series circuits are essentially, break it down in the simplest form, is that the current has one path to flow from the voltage source to ground, which is essentially back to the source again to complete that circuit. It does not matter how many resistors are in the circuit, because we can have one or we can have more than one. And I mean, we can continue to do this and we can go 12, and so on. So the more resistors we have in a circuit, it simply means that we're going to change the total resistance. So let's talk about that first. So when it comes to a series circuit, if it has just one path to ground through one resistor, we only really need to know what the resistance is in this circuit, and we measure that in ohms. In a circuit with multiple resistors in a single path, what we have is we have a combined resistance. All right, so my first resistor is 4 ohms. My second resistor is 2 ohms. And I know that because I would make my measurement with the power turned off across each resistors. So what we do for the math of this is we go resistance total equals resistor 1 plus resistor 2, which is equal to 4 ohms plus 2 ohms, which is total resistance of 6 ohms. All right, and again, I'm using very simple numbers just to show you the method in which we need to be able to do this. All right, so with this, and in a series circuit, we know that the rules for power apply. So we're going to look at this in Ohm's law. Ohm's law is EIR. I know we've talked about this, where it's voltage, amperage, and resistance. All right. So we know that we have 12 volts, and we know that we have a total of 6 ohms. All right. So with that information, I can calculate that my current is 2 amps. All right. Now, with this, when we were measuring that, if we were to put an amp meter in here, it would read 2 amps. All right. So there's something else we're going to talk about too, which is Kirchhoff's law. All right. Kirchhoff has 2 laws. All right. And of the 2 laws, there's a law for voltage, and there's a law for current, or amps. All right. And I'm going to use these, and I'm going to talk about these in class, but very quickly we're going to cover these. All right. Kirchhoff's law of voltage says that as we go across from one end of the circuit to the other, all voltage must be used. All right. So, and with that, I mean, I don't have room to write it, but it is is used proportional to the resistance that it is going over. All right. So in this single resistor, if this was doesn't matter what the resistance is, I could say 6 ohms, we would know that we would have 2 amps going through here as well. But my total voltage would be dropped over there. And if I was to take this meter and switch it from reading ohms to reading volts, I would see that all of the voltage would drop over there. And that test is done while the power is on. All right. Now, with this one, we have a little bit of a difference. All right. So in this one, first thing we did was we calculated what the total resistance was going to be. All right, and we came up with 6 ohms. And with that information, then we used Ohm's law, and we figured out that we would have 2 amps. But now what I can do is I can calculate what the voltage drop would be across each one. Because Kirchhoff's law of current says that the current flow through a circuit at the point where it enters a circuit has to be the same as where it comes out of a circuit. And because a series circuit only has one path to flow, it means that I could install my amp meter at any location in this circuit and I would always get exactly the same reading. All right, but we can use this to calculate the voltage drop across each of these resistors based on what we know. We know 4 ohms and 2 ohms. We know 2 amps. So 2 amps times 4 ohms means that I would drop 8 volts over that resistor. And 2 amps times 2 ohms means I would drop 4 volts over this resistor. Well, with that, and again, we could look at this. My voltage drop here, my voltage drop, if I add my voltage drops together over this, it equals 12 volts. Make that a V, not a U. All right. So we can see that rule applies. All right. Okay. So I have another circuit on the board now, and I'm just going to show you what we can do with this and how we may have to go through a couple of steps in order to find all the information that we're actually looking for. So I have 12 volts as my source voltage. Amp meter is showing that I have 1.5 amps running through my circuit. I've got a voltmeter connected over the first resistor. All right, so let's do a couple of things here. Let's see. Okay, so now tell me what would be the voltage in the second resistor. Well, we know using Kirchhoff's law that all of the voltage has to be dropped over the circuit before it gets to ground, but it is dropped proportional to the resistance. Now we know that if we've dropped 3 volts out of my available voltage on the first resistor, what can I assume that my voltage drop is on the second resistor? Well, 9, because 9 plus 3 equals 12. So we're going to say that the voltage drop over the second resistor is 9 volts. And we can measure it, but we can actually calculate it. Now with that, I could say, now I want to know what the resistances are for these 2 resistors. All right. So again, I can solve this mathematically without having to measure it, or I can measure it and prove that I am correct. So I know that I have 1.5 amps running through the entire circuit, and that doesn't matter where it is. So I can apply this 1.5 amps to the voltage to find out what the resistance is. All right. All right. So we're going to use Ohm's law to calculate this out. Now we know that E over I times R. Now in this case, we're not using the 12 volts. We're going to use the 3 volts that we have here. 3 volts. 3 volts here. All right. And we know that the current is 1.5. All right. So 3 divided by 1.5 means that this resistance is 2 ohms. All right. And so now for the second part of this, what we can do is calculate R2. We go again, E, I, R. We know that our voltage for the second calculation is 9 volts. We know that the current going through my circuit is still 1.5 amps. Get rid of this so it doesn't think we're 11. All right, 9 divided by 1.5 is 6 ohms. All right, so we know that this first one was 2. This one is 6 ohms. All right, so now we can look at this and we can go back and try and prove the whole thing. So if we know that 2 plus 6, because the law for a series circuit when we have multiple resistors is that the resistances are added. So 2 plus 6 is a total resistance. Eight ohms. Now, again, we can always prove this, go back and prove and check your work and make sure that everything works. If we know that this is 1.5 and we know that this is 12, then 12 divided by 1.5, we do the math, equals 8. So everything comes around and everything proves that the other things are true. And you can see that when we started this, we had 2 single pieces of information. Now, if this was multiple resistors, you just simply have to go through and do the work and follow along, and eventually we'll get all of the information that you need.